Hello everyone, this is Adil Ahmed. My student ID is 440864 This is my student ID card. Today I'm going to present my dissertation proposal titled Detecting AI Generated Deepfakes for Mitigating Advanced Social Engineering. This research is being conducted as a part of my MSc program at London South Bank University. So to start, let's define the problem clearly. Deepfakes are highly realistic synthetic media, videos, images, or audio generated using advanced artificial intelligence algorithms. While AI offers tremendous benefits across the healthcare, education, and entertainment, it also introduces severe threats, especially when deepfakes are exploited in social engineering attacks. Social engineering refers to a technique that tricks individuals in compromising sensitive information. When enhanced by deepfakes, the attacks are extremely persuasive and challenging to detect. My rationale for this study is pressing need to safeguard individuals and organizations against these threats using robust and scalable AI detection methods. Key theoretical concepts include deep learning architectures like CNNs, recurrent neural networks (RNNs), and the ethical implications concerning data privacy under guidelines like GDPR. So in reviewing literature, several influential studies stand out. Efker et al. Introduced Masonet, a CNN designed specifically for facial video forgery detection. Rosser and colleagues effectively utilized ExceptionNet, demonstrating high accuracy on the face forensics dataset, though performance diminished when videos were heavily compressed. Then there is Zhang et al. Who introduced GAN fingerprinting, leveraging frequency domain analysis to spot generative artifacts in deepfakes. Then there was Mr. Patel's work, which efficiently employed RNNs and LSTMs for temporal inconsistencies in audio deepfakes. Finally, Samin and Prakash emphasized explainable AI methods, highlighting the importance of transparent decision making within deepfake detection platform. So the research aim and objectives were straightforward. Can advanced AI-based system effectively detect AI-generated deepfakes, particularly in sophisticated social engineering attacks? To answer this, my aim is to develop and validate a comprehensive practical deepfake detection framework that integrates seamlessly into existing cybersecurity infrastructure. Objectives include critically evaluating current detection techniques, analyzing documented social engineering attacks involving deepfakes, identifying existing limitations, proposing a viable framework for detection, and addressing the ethical and societal impacts of these technologies. So the research methods that I use were mixed method approach, combining qualitative and quantitative analysis. I plan to collect data from publicly available deepfake datasets such as Face Forensics Plus, DFDC, and SlabDF. My analysis will use deep learning models, especially CNNs for spatial features and RNNs for temporal features. Ethical considerations are paramount. All data usage complies strictly with privacy regulations such as GDPR. The effectiveness of these models will be evaluated using standard performance metrics that are accuracy, precision, recall, and the F1 score. So the data collection, processing, and analysis In detail, I utilized established datasets: Face Forensic++, DFDC, SlabDF, which provide a robust basis for training and validation. Pre-processing includes resizing images, videos, normalizing color, and extracting critical frames. Feature extracting will leverage CNN architecture like ExpositionNet and MesoNet for spatial analysis, while RNN and LSTMs will examine audio-visual inconsistencies. Analysis involve rigorous statistical validation, ensuring reliability and generalization across diverse data inputs. Then there are machine learning techniques and visualization. There are CNN for detecting visual artifacts, RNN STM network for identifying audio and video anomalies, GN fingering to trace characteristics, generative patterns. So the timeline and planning of this project or dissertation follows a carefully structured timeline depicted by my Gantt chart. Key phases include proposal formulation, comprehensive literature review, methodology, refinement, collection of data, analysis, report drafting, personal reflection, and final presentation. Risk management. So I have actually identified several potential risks that include dataset availability. I have gone through many data sets that I have previously told. There are technical challenges that are addressed through reliance on open source tools and strong community support. Then ethical approvals, score creep managed through frequent supervisionary consultation to maintain clear and realistic research boundaries. My personal reflection is the research has been both challenging and enlightening. Initially, I aimed for extensive technical experimentation, but quickly realized limitation due to computational resources. Instead, I adapted my focus towards developing a robust conceptual framework. Through this process, I've gained deep insights into not only technical aspects such as GN architectures and adversarial robustness, but also critical ethical and legal implication. Finally, these are the references that I have collected, and thank you very much for your attention today. Bye-bye.